A few days ago, I was listening to a podcast of Unnecessary Detail. Super interesting podcast of Unnecessary Detail, hosted by Matt Parker, Steve Mould and Helen Ani. And in the last episode, Steve was talking about excitable media. Those are, very shortly summarized, media that can be activated in a way, and when it's activated, it spreads to media around it, but once it has been activated, it takes a while before it can be activated again. And that can create interesting dynamics. Steve just posted another video where he gives a great example of lighter fluid into a circular track. And you can clearly see the wave rotating around the track. And during the podcast, they talked about how a forest fire could also be an excitable media. The forest burns down, it spreads to neighboring forests, but once it has been burned down, it takes a while for it to grow back and to be able to burn again. And then Matt asked a very interesting question.
How big would a planet have to be? So, if you had a continuous strip of land around around the equator, around a great circle, by the time the fire got all the way around the planet, the forest is regrowing.
How big would a planet need to be able to sustain a continuous forest fire? Meaning that once the forest has regrown, the fire front has made a lap around the Earth and can start all over again. But right after that, he simplified it to how long a ring forest needs to be to sustain a continuous forest fire. But why the simplification? Because so many interesting things happen when you look at a sphere rather than just a flat surface or a single line. Just think of the Coriolis effect that turns the winds to the east, or just think of the problems with map projections, for example. Spheres create such interesting geometry and such interesting mathematics that it's a shame to simplify this example to just a ring. I wanted to dig a little deeper into this question, so I wrote some terrible Python code. Just kidding, it's JavaScript. Oh, it's still terrible, but I wrote some terrible JavaScript code. So I created a very simple example first, and just like Steve, I noticed that you really need to block the start of the wave, or otherwise it would just extinguish itself on the other side. And what I did next was just to recreate the ring example, so we start from the same place, and as expected, this works fine. I can see why you would want to simplify it to a ring, because the mathematics become a lot easier. And one of the listeners already did the maths and came to the result that the planet would need to have a circumference of 87,600 meters for a forest fire to continuously sustain itself. But I wanted to dig a little deeper and see how big a spherical planet would need to be, and if there's any difference, like is it the same answer or does it need to be bigger, can it be smaller when you look at the entire planet? And indeed, when just making the simulation a single ring, it works as expected, and we can assume that this planet would have to have a circumference of 87,600 meters for this fire to continuously sustain itself. Now I wanted to see if we made this ring wider and more of a sphere shape. How does this mechanic change? So I did just that. I made the ring wider, so the ring had more of a curve and slowly over time becomes more of a sphere shaped rather than a ring shape. And it takes a while for the pattern to establish, but once it's fully established, it's really interesting because the fire now continuously rotates around the poles and then just spreads down to the equator. And it seems that if you want a fire to sustain itself, it just needs to be able to rotate around a polar area with a circumference of 87,600 meters. And as this polar area gets as small as possible, the world really gets as big as possible. So you could assume that if you want this forest fire on a completely covered planet, the planet would have to be infinitely big. But that's actually not the case. But look at what happens at the simulation when I make these polar areas too small. The forest fire actually starts to rotate around the barrier that we designed first. And if we let this run for a while, it just keeps rotating around this barrier. So we don't actually need something to rotate around near the poles, we just need anything to rotate around. And the entire trajectory needs to be 87,600 meters, but that means that a line to rotate around can just be half that length. So in theory, if we can fit a line of 43,000 meters on the sphere, it should be enough to sustain a forest fire. It takes a little bit of tweaking of the starting conditions to make the fire rotate once around a single line rather than just twice. But I eventually got it to work. And when we think about how big a planet needs to be to fit a line of 43,000 meters, That's again a planet with a circumference of 86,600 meters. So you didn't even have to simplify the question to a ring, because the answer for a completely covered sphere is exactly the same. You just need to have some barrier on this planet with a circumference of 86,000 meters. And that's about how deep in this rabbit hole I want to go, because I just found out about detonation engines, which have a very similar principle, and I guess they also have a lot of physics behind them.